In this next video, we're going to take a look at a data set where autocorrelation can be a problem. So you can see in your notes there that I've got this production data. It's a CSV file, so we want to read it in again, using the read.csv command. And I'll type head data, and you can see sort of what's going on here. These are the day numbers in order that a company has tracked its sales and production. A natural thing might be to model their sales versus how much they produce. Okay, and so take a look at the output of that linear model, and we can see the R-squared value is not great. These are our intercept and slope for the model. Of course, I could make a plot and drop a line on that plot. I like those blue lines. I think they're pretty cool. And where did it go? It's not there. These are some old things. I don't know what all this stuff, chimpanzees and stuff. There we go. So there does seem to be some sort of a positive association, but it's not extremely strong according to our R-squared value. I can of course get the residuals. I could do it the old-fashioned way, or just type residuals. Remember, now that I have my output, it's the residual column from output. Residual is so there they are. If you want to see those, let's make another graph here, and in this graph, I want to put three things down. Okay, so let's do them all side by side, or one over the other. Let's do 3 rows in one column. Okay, and I want to plot. First of all, I want to plot the residuals versus production. Okay, and I'm gonna be a little lazy here, and I'm not gonna label that. I've got residuals versus production. Okay, and in the next plot, I'm gonna and I'm also gonna drop a regression line, or not a regression line, but a horizontal line there. That's kind of nice, so that you can compare the residuals there. You should be seeing the sort of an equal variance across there, and hopefully some kind of normal behavior from day to day. Plot, or as you move from left to right. If I plot sales versus day, however, look at this. It looks like the sales have something to do with the day, don't they? As we move throughout the couple the 2 or 3 month period here, it looks like the sales are going up. So maybe they've implemented some new strategy. Maybe this is a seasonal thing. Maybe this is the start of summer and something's exploding here. But it looks like the sales have something to do with the day, don't they? Okay, so there are really 3 variables here that sort of seem to matter. We haven't really talked about how to treat 2 of 3 variables as predictors yet, but that's definitely coming. Let's now take a look at the residuals versus the day. Okay, again, you sort of see that the trend there. Okay, these residuals, by the way, are the ones from our when we looked at sales versus production. Okay, so what I'm sort of concerned about here is whether or not these residuals have any kind of autocorrelation. That is, are they correlated as you go through time? Are they or you can think of it as, is the distribution of this one, is it somehow is it does this one's behavior depend on the ones that are immediately preceding it or something? Okay, so I can actually tackle this with something called a Durbin-Watson test, or maybe you call it a von Neumann-Durbin-Watson test. John von Neumann had something to do with this test. So, but in the CAR library, CAR, not CARS, this is the Durbin-Watson test, and I will run that on my output, and yeah, okay, the p-value is essentially 0. It's looking like there is some sort of autocorrelation between these across the residuals as you go through time. So that's kind of a problem.